Okay, so this is 7.4, Matrices and Systems. All right, so a matrix is a group of numbers organized in rows and columns. Okay, so we're going to draw a matrix. Let's call this an M by N matrix. Okay, and then let's draw this. So A sub 1, 1, A sub 1, 2, and then A sub 1, N over here. And then we'll call this A sub 2, 1, A sub 2, 2, dot, 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 A sub 2, N. And then we got some stuff going on in between. A sub M1, A sub M2, and A sub MN. Okay, so this M represents your row number. Okay, so the M is your row number. And the N is the column number. Okay, so this is like row 1, and this is row M. Okay, this one is column 1, and this is column N. So you name it row by column, okay, so, you know, depending on how many rows you have, that's the number that comes first, and then how many columns you have is the number that comes second, okay? So, for example, and each one of these is elements, so I guess let's label that too. This is an element of the matrix. Okay. So if you have the element, let's say A sub 4, 1, okay, it means this is in the 4th row and the 1st column. You remember this stuff from last year? Did you guys do matrices last year? No. Yeah, you did. Looks familiar, but like, yeah, it was probably like a real quick thing. Okay. All right. Well, everybody okay with the definition of a matrix and kind of what it looks like? And then they have these, you know, brackets, okay, around them. Okay. So a linear system. Oops. Of equations can be written as an augmented matrix. Okay, so we're going to talk about an augmented matrix now. So I guess I mean, I don't know. I don't think this has to be an example. We'll just keep going here with our definitions. Let's say, for example, you were given this system of linear equations. X plus y plus z equals 2. And 2x minus y plus 3z equals negative 1. And negative x plus 2y minus z equals 4. Okay, so last year in Algebra 2, I'm sure you solved systems of equations, probably with, you know, elimination or substitution. And I'm guessing that you only probably solved for 2 variables. You probably had like 2 equations and maybe they had 2 variables in them, right? But that's not always the case with systems of equations. Sometimes we can have many more variables and many more equations. All right, so here we have 3 variables and 3 equations. So this would be much harder to solve by hand, right? And this will take a while. So matrices are a way that we can solve these. Okay, so this is why we use a matrix. Okay, so the first thing you do is you take all the coefficients. We're looking at all the coefficients on the left side, okay? And you always want to make sure that you have a place for everything. So let's say, for example, the second equation was missing the y. You'd have to put in a placeholder of 0 there. Does that make sense? Okay, so you want everything kind of lined up. So I'm going to have 1, 1, 1. I'm going to come back to the equals stuff in a minute, okay? Then I'm going to have 2, -1, 3, and -1, 2, -1. So I'm just taking the coefficients of each one of those variables, and I'm making sure that all the variables occur in the same order. So they all come in X, Y, Z order. Okay? You with me so far? Then there's this like little dash line. All right? You can kind of think of it like that's representing the equal sign. All right? And now we have all of those, what this is equal to over here on the right side. So we have 2, -1, 4, and then we close our bracket. Okay, so now let's talk about what these pieces are. So this right here is a 3 by 3 coefficient matrix. Okay, it has 3 rows and 3 columns, and that's why it's 3 by 3. Okay, then over here we have a 3 by 1 constant matrix. Okay, because those were our constants of our equations, right? This is 3 rows, 1 column, so that makes it that 3 by 1. Together, this forms our augmented matrix. So this is an augmented matrix. Okay, you might want to make yourself a note there. If terms are missing, use a placeholder. Okay, I would probably write that in. So fill in missing terms with a placeholder. And you know that placeholder is 0, correct? Okay, are there any questions so far? Just kind of talking about definitions, right? Pretty easy so far? Okay. The next part is probably the hardest thing that you have to do with matrices, okay? Because it's looking for patterns. And sometimes students don't like that, okay? So that's what we're going to do next. We're going to talk about elementary row operations. Okay, so there are 3 that we're going to discuss. The first is that you can interchange 2 rows. Oops. Yep, okay. So that's the first one. You can interchange 2 rows. The second is you can multiply one of the rows by a non-zero constant. So like I could take row 2 and multiply it by 3. Okay. Number 3, you could add a multiple of one row to another. Okay, you can also like combine these and do multiple things in one as well. Alright, so you can kind of combine these operations as well. Okay, so that's what we're going to do right now. We're going to take a look at some patterns and try to, kind of determine what it would look like if we were to perform these row operations on them. So let's call this example 1. Write the system into an augmented matrix and then perform the row operations. Okay, so let's say we were given this system. X plus 3y plus 4z equals 0. 3y minus z equals 2. And x plus 2y minus 3z equals 4. Okay, so the first thing we're going to do is we're going to create this augmented matrix. So remember, that's going to be those coefficients first, the dashed line, and then our constants afterward. Okay, and anywhere we don't have a term, we need to make sure we have a placeholder. So does everybody see we're going to need a 0x here? Okay, everybody see that placeholder we need? Okay, so let's go ahead and write that augmented matrix. So we're going to have 1, 3, 4. You can kind of draw that dashed line in there. And we have a 0, right? And then 0, 3, negative 1, 2. And 1, 2, negative 3, 4. Everybody okay so far? Okay, so let's start some row operations now. Okay, so what if I told you to interchange the first and third row? Now let's think about this for a second. Everybody agree this is like row 1, row 2, and row 3, right? So you got to think about it like that. We don't worry about the columns with these row operations. We're just focused on the rows, okay? So if I got to interchange the first and the third row, shouldn't this just look like 1, 2, negative 3, then 4? And that middle row should stay the same. And then the first row moves to the third. So 1, 3, 4, and 0. Right? All you've done is literally flip-flop those two rows. So far, so good? Okay. What if it said to multiply row 2 by a negative 1/2? Okay, now remember, we're always going back to the original, okay? So first of all, if you were going to write this as like a notation, you would want negative 1/2 R2. Okay, that's what that could look like. All right, you're just saying you're taking that constant of negative 1/2 and multiplying it through row 2. So what would this matrix look like? Just in the middle, right? Like everything would be the same up top, right? And the third row would stay the same. So the only thing that should change is row 2, and all you got to do is multiply it by a negative 1/2. So 0, negative 3/2, 1/2, negative 1. Everyone agree there? I'm kind of running out of space here. All right, you try this one. Add negative 3 times R1 to R2. Times. Okay, so like if you were going to do the notation for this, you could write it like this. Negative 3 R1 and then plus R2. All right, that's what it would look like. Yeah, Tiffany. You're actually, when we do the quiz, you're actually going to tell me what happened. So I'm not going to, you know what I'm saying? Like I'm going to give you these two, and then you're going to have to tell me you got to interchange this, or you got to multiply by this. You're going to tell me the pattern. Okay? And to be honest, I don't care if you use notation or if you explain it in words, as long as it makes sense. Okay? So why don't you go ahead and try to figure out what that one looks like. I'm going to fit it in here. And then I'll give you a second to do that. Okay, so is row 1 going to change? Nope. Is row 3 going to change? No. So the only thing that should change is row 2, right? So everything should look the same except row 2. And then for row 2, did you get -3, -6, -13, and 2? You have to multiply row 1 by -3. So I get -3 there. And then you have to add it to 0, right? So you get -3. Then I take 3 multiplied by -3 to get -9, but then I have to add it to this +3. It's giving me -6. You with me? Everybody okay? Moving on. Okay, we're going to do some calculator stuff now. So go ahead and get your calculator out. All right. I guess we only did one example, huh? So we'll just call this example 2. And we're going to use the graphing calculator. Yeah. Mm-hmm. But you have to add it to row 2. Yeah. Right? It's -3 times row 1 plus row 2. Yeah. The constant?
No, the one to the left. You did -3 times 4.
Which is -12. And then you have to add it to -1. Okay. Everybody okay? Okay. So we're going to use the graphing calculator to solve this system. Okay, so we're going to be given a system of equations again. All right, so this is our system. 2x minus y plus z, leave a space, equals 7. And then x plus y minus z plus 3w equals -4. And then x minus 4y plus 3z minus 2w equals 18. And then y plus z minus w equals 1. Okay, we would not want to attempt to solve this by hand. Okay, so we're going to use matrices to help us. Okay, so there's a process you have to follow. Okay, the first thing you want to do is, well, go ahead, I'll let you write this down before I keep talking. Okay, so the first thing we want to do is we want to create the augmented matrix. Okay, well now in order to create it, we want to remember we need placeholders where we don't see those terms. So if you want to write them in, you can, or if you just remember to fill them in, I really don't care, just don't forget them. So here we're going to need a 0w, and here we're going to need a 0x, right? So those two terms are missing, we want to make sure we put placeholders in. Alright, now we're going to create the augmented matrix. So step 1 is the augmented matrix. Alright, so let's go ahead and fill in those coefficients. So 2, -1, 1, 0. You go ahead and make yours and compare it with mine. You got to be really, see, here's the thing with matrices, is this is so easy, so we tend to want to go quickly, not pay too much attention because it doesn't take too much thinking, but if you type in one of these numbers wrong, or if you write one of these numbers wrong, your whole answer is going to be wrong, okay? So you want to be careful, double check your work. Okay, everybody all right so far? You have those two placeholders of 0, okay? Now, this is what happens. Two matrices are really created here with this augmented matrix. There's this coefficient matrix, right? So this is matrix A, we're going to call it. Okay, this represents our coefficient matrix. What are the dimensions? 4 rows by how many columns? Just count. 1, 2, 3, 4. It's a 4 by 4. That's it. Okay? Okay, so the matrix is a 4 by 4. That's important. We need to make sure we know how to do that. All right? Now, the next one, okay, we're going to call it matrix B. And remember, this is like our constant matrix. Okay, let's try this again. What are the dimensions of this matrix? 4 by 1, right? 4 rows, 1 column. So this is a 4 by 1. And this is really important to know your dimensions. Okay, so that was step 1. Easy, right? So far, so good. Step 2. You are going to create the matrices in the calculator. Okay, so we have 2 matrices to create. Here is A. Okay, so this is matrix A. We know that it's a 4 by 4. And it's going to look like just those coefficients. So 2, -1, 1, 0. 1, 1, -1, 3. 1, -4, 3, -2. 0, 1, 1, -1. Then we have to create our second matrix, matrix B, and that one's going to be a 4 by 1. And I mean, they're your notes. It's your choice. No, I don't really care. Yeah. So then the matrix for the constant is going to be 7, -4, 18, and 1. Okay? So now let's figure out how to do that in the calculator. Okay, so you have to find the button that talks about a matrix. All right? That's going to be on the left column. Okay, and it's the inverse key. So we're going to hit shift or second matrix. Okay, and then this menu is going to pop up. Does everyone see that? Everyone get that menu on your calculator. Okay, now the next thing you have to do is you have to edit it. So you're going to arrow over and you're going to edit. Now what happens is every time we reset our calculator, this is going to get cleared out. So if you have any matrices in here and you want to clear them, you can just reset the calculator and kind of start over. Okay. So I already have matrix A. I'm just going to go with that. So you're going to hit enter. Okay. Now you have to tell it the dimensions. So you got to remember how to figure out the dimensions. Remember, the dimensions always go row by column. So this is a 4 by 4, so that one's kind of easy. And the calculator will create all of those places to put your elements in. Everybody get that? Okay. Now, this is the part where I'm warning you. Please, please take your time and make sure you enter them in correctly. I know it's a pain to double check your work, and you hate double checking your work, but do it anyway. Okay? So let's type it in. You just hit enter each time you type in a number. Then it'll jump to the next row. Okay, so make sure you have your, you can't even see mine. Make sure your matrix is entered correctly. Okay. All right, so now, everybody have that? Okay, set this aside. We're gonna come back to this in a second. So just set your calculator aside for a second. And now we're gonna talk about step 3. So step 3 is to solve for the variables. Okay, so in order to do that, it's basically like you're solving, you know, for some variable. So we'll just call it X, the variable matrix X, okay? What you do is you take A's inverse, so the matrix of A's inverse, and you multiply it by matrix B. Okay, this will produce your variable matrix. Let's label this. Variable matrix. Okay, this is going to produce all of our variables for us. Okay, so everybody ready to try it? Okay, it's pretty cool. So you're going to go back into the calculator. All right, you're going to quit out of this phase there. So quit out of that. All right, and now you need to take the inverse of A and multiply it by matrix B. So we have to go back into the matrix menu. And this time I want to recall A. So I don't have to arrow over to anything. I just hit enter. And it will bring that up to the main screen. So I have matrix A, but I want the inverse of it. So you have to hit the inverse key. X to the -1. And now matrix B. So go back in your matrix menu. We never entered matrix B, did we? Okay, rewind. We got to go back in and do that. So arrow back over to edit. Arrow down to B. And this is a 4x1. Okay, so I had 7, -14. Nope, I almost did it wrong. -4, 18, and 1. Okay, double check your work. I just made 2 mistakes, so I would have been really wrong. Okay, everybody okay with that? Okay, so now let's quit out of that again. So we should still have our inverse of A. And now I want to multiply that by matrix B. So you go back into the matrix menu, arrow down to B, and hit enter. Isn't that cool? This is X, this is Y, this is Z, this is W. Just like that, you're done. Been a nice trick to know last year, wasn't it? You did? Yeah, good. 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 Okay, so now when we write our variable matrix, okay, we just write it like, it kind of looks like just a constant matrix. So it's 1, -2, 3, and 0. Okay, now if I was to ask you for the answer, which I am, right, I'm asking you to solve for the variables, you would not give your answer like this, okay? Your answer would look like X equals 1, Y equals -2, Z equals 3, and W equals 0. And that is our solution. Okay? Any questions?